Hello, I'm Matt Eland, and I want to talk to you about leadership in software engineering spaces. I've been privileged enough to be a software engineer professionally for the last 20 years. I have had positions anywhere from a junior developer on a team to mid level developer to senior to team lead to engineering manager. Now, presently, I am a senior solutions developer too at Leading Edge, where I'm a consultant helping organizations to understand what makes good software and good software engineering teams and help them expand their code, clean up the things that they have in the past that maybe are haunting them a little bit, and things like that. It's really not feasible anymore to think about all the ways a code might be over the course of its life. Instead, you build your software code to meet a certain set of requirements, knowing that they're going to change over time, knowing that they're going to grow, evolve, morph, and the like as well. Now, as your requirements change over time, your existing code doesn't unless you as engineers change it. So this is where the term technical debt comes from that you've likely heard around in software engineering worlds. So technical debt is essentially any code that we have that is really not what we would have written it today. It doesn't support the cases that we're trying to support today. It was built for something else. It might have been built on an older technology. It might have been built on faulty assumptions. It might have sometimes even be built by somebody who really hadn't had that cup of coffee in the morning and probably should have taken a little bit more time. But sometimes technical debt just occurs normally as technology changes and grows. And a story of that from my own career is I was a specialist in a technology called Silverlight, ran rich applications in your browser. It let you do really amazing things, build amazing applications for people. And then all of a sudden, Google says, "Hey, uh, we think that Silverlight and Flash are maybe performance hogs and security risks, and so we're going to make sure that Chrome doesn't support these things out of the box." So this fancy new application that we were all building, all of a sudden that became technical debt, and we had to replace it with something else. In this case, JavaScript. Now, uh, that is a very specific example, but that's the kind of thing that will happen in technology. The latest and greatest new framework over time it's not as good and not as good as it could be. But that's normal software engineering. So what does this have to do with leadership? Well, it has to do with this code that is not what it should be right now is going to slow you down over time. As you try to add a new feature, it's going to slow the rate of development. As you make a change, it increases your risk of adding a bug while you're doing that because the code was not built to support what you're trying to do right now, or because it wasn't built the right way, or the technology has changed, any number of things, right? So this technical debt that we have in our old code that poses a risk to the business going forward as we try to add new features, as we try to fix bugs, as we try just really to support the business. And so engineers are torn in two different directions. In one place, they want the code to be perfect because, we're engineers, we want things to be well engineered. On the other hand, they want to support the business requirements, right? Now, the way that this often works out is engineers want to make the perfect system. They want to spend all their time making something great. And meanwhile, business is saying, well, we need this feature now, 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 now. And this can lead to kind of an adversarial relationship where the business doesn't necessarily understand what's easy and hard about software engineering. And at the other hand, your software engineers don't necessarily understand the business and the customers and the needs and the fiscal schedules and when these features have to be ready and the initiatives we're trying to complete. And you have this disconnect, and you have these two halves that are really at odds with each other in the same organization, and it can evolve into this really unhealthy thing. So how do we fix this? How do we help our software engineers and our business folks work together? How do we help have a healthy code base that it supports good working conditions, supports lowered risk of introducing bugs as you make changes, and supports the needs of the business? I'm going to say something interesting, and that is every code change that a developer makes should be to support the business. Okay? That code change may be to add a new feature. That code change may be to fix a bug. That code change may be completely transparent to the organization as a whole. you're cleaning up some code that could be in a better form. We call this refactoring. This is changing the form of something without changing its behavior. I'm actually writing a book on this at the moment, refactoring with C# through packed publishing. Uh, but any change that occurs to a software system should be to benefit the business and the business's customers and stakeholders. Okay, so does that mean that our software engineers should not pay down technical debt? They should not improve code that's already existing? Should they just add new features that the organization needs? Well, no, because at some point the whole thing is going to get so riddled down that you're going to need a consultant like me to unravel it, right? And you don't want that. You want to have a healthy balance of meeting the needs of your customers, your stakeholders, your new features, while also providing developers with the opportunity to have maintainable code that they're not going to be at risk of breaking. As far as engineering and the business, well, I think that there's a conversation that needs to happen that usually doesn't. And that conversation is that the business needs to see things the way that the engineers do. And the engineers need to see things the way the business does. So what do I mean by that? Well, your engineers are terrified to change certain areas of your code because it's so complex, so muddled down with technical debt and legacy code that they don't want to touch it with a nine foot pole, right? They need to be able to communicate that to management and say, hey, we have significant risk in this area. We're not sure we can safely maintain that. And they need to be able to tell management that without fearing their jobs, right? On the other hand, management needs to be able to say, hey, we have this really critical need to ship this feature by the end of the month. This is what's going to happen to us if we don't. These are the good things that happen if we can. I understand this is not ideal right now with the code, but what can we do to ship this and then come back and address that? And I think what this looks like is a risk management process. I think that the engineering organization and the business organization, you have your engineering leadership and your business leadership come together and say, hey, what are the greatest risks that are facing you in your code base? What are your greatest technical risks? It might be code that's prone to breaking. It might be performance issues with slow code that needs to be optimized. It might be fears of security issues. It might be fears that something is going to be out of date and needs to be updated. Whatever it is, you can track it in a risk register, which is really just a spreadsheet. Like, hey, these are all the risks that we have as an organization. Here's what we think the highest priority is. Here's how long we think it will take to address each one. And now that's actually business value that the business can understand. It's like, oh, you're saying that by refactoring or improving this complex area, we are addressing these potential risks, which may cause us to lose a lot of money, a lot of public face, a lot of reputation, whatever. Oh, okay, I can understand that. I can understand prioritizing that. I don't understand the technical concepts you're talking about, but I trust you. And that trust word, I think, is important. So we need to get to a point where our engineers can trust the leadership and the leadership can trust the engineers. On the other hand, that means that your engineering leadership needs to be able to see the business value of things. They need to be able to see beyond the technical, beyond the implementation details, beyond the schedule details. They need to see the actual value that the software provides their users and their stakeholders, and the value that the business schedules have, right? Your business has timetables for a reason. Your business has a roadmap, your KPIs, all these things, right? Your engineering leadership needs to be able to understand them and work to them, because sometimes it is better to incur a lot of technical debt to ship some features. Sometimes that's the way to keep the lights on. And sometimes it's time to pay down some of that technical debt. Usually there is a balance that you need to have. But it all boils down to having a healthy conversation and talking with management and say, hey, this is what we're concerned about. This is the things that we think might break. Hey, that bug that occurred last week that was high profile, we could have prevented this or remedied this a little easier if this other thing had been addressed previously. And so it's this ongoing conversation you have maybe once a quarter, once a month, something like that, where you say, hey, here are our greatest risks. Here's what we're doing to remediate them. And you allocate a certain percentage of your capacity towards paying down these technical debt issues, getting ready for future initiatives, things like that. And the rest of your capacity is going towards short-term, medium-term business needs. And that lets you get a very healthy and high velocity approach to software development. but it all starts with trust. And that means your business has to trust the developers, your developers has to trust the business. Get people talking to each other, get people communicating the same language, which is a challenge with developers, then you can really start rowing together and accomplish some great things that last a very long time. Thanks for watching, and let me know what you think. I'd love to hear about your stories with dealing with technical debt, ways that you've been able to handle it well with your teams, ways that you've been able to help your engineers understand a little bit more about uh, really the business concerns. But happy coding, happy building whatever you're building, and I hope you do it well.